Hi Zia, my name is Anna Leszkowska and I would like to teach you about architectural technology. So the first session we're going to start with this book here, which is called Bautechnik-Tabellen, which means building technology and conversion tables and all this sort of boring stuff. That's kind of important to be able to do the job properly. So this book has different chapters, 1 to 10. We're just going to go through it one by one. The first is about math, second is about mechanics, the third is about building physics, the fourth is about building materials and structures, the fifth is about bricks, sixth is about steel and concrete, seventh is about claddings and tightness, the eighth is about scaffolding, the ninth is about timber construction and internal works, and the 10th, which is my specialty and favorite one, is about drafting, because I'm a draftsperson. So yeah, so we learn everything about how to build and design a house step by step and everything necessary we need to know about it in theory. And then hopefully we'll get the opportunity to do the practical bit as well and go through a real life project. So okay, let's just take it easy and start with formulas and different signs and formulas, which are mainly derived from the Greek alphabet, like from alpha till omega. So A means the surface, B is the width, D is the diameter, or the thickness, E is the middle part, F is sort of the if someone's bends, H is the height, I is Trägheitsradius, means the radius, K is the Krümmung, which means how it also gets sort of bent. Sorry, I just have to translate back and forth from German to English, so bear with me please. You might pick up some German words as well and learn German at the same time. So L is the length, O is the surface, R is the radius, S is the length of the waves, T is thickness, U is the Umfang, which is the if you go around the perimeter here. V is the volume, W is cubic meters, R like R, that's the K, so do with the R value. X, Y and Z are the coordinates in the space, so you know if you draw 2 or 3 dimensionally, if you draw just 2 dimensionally, you just get X, which goes horizontal, and Y which goes vertically, and if you go to 3rd dimension you also get Z, which is the 3rd dimension to show the volume. Then we've got A, the degrees. Now this starts with real Greek letters, which I don't know how to pronounce. By the way, my best friend is going to Greece next month. I'm really jealous here. I wish I could travel overseas. T is the time extension, and F is the frequency in hertz or megahertz. V is the speed in millimeter per second. C is the speed of the wave, how sort of the wave, light or whatever spreads out in space. A is the acceleration. G is the acceleration of a fall. N is the number of our rotations. V is the speed of that's a degree and a pitch. C is the speed of the light in a vacuum space, it means kilometer per second. And Q is the stream of volume, Volumenstrom, how something sort of goes through metal. And yes, so there's the abbreviation in relation to time and volume, Raum und Zeit continuum in German. The next ones are mechanics and warmth and electricity and light. Just probably it's not so relevant, to be honest. And then we also got different letters and abbreviations for topics like it's called sound, and also in building for different materials. So, but we'll just skip that and move on to the next chapter. Yeah, that's probably more relevant, which is talks about signs and letters for mathematics and calculations. Yeah, obviously everybody knows plus and minus, and division, equal, unequal, approximately equal, more or less, different, something eternity, light for some, and degrees. Well, I could write it out and email it to you if you're interested specifically in those letters or signs or abbreviations, but this is obviously general knowledge at intermediate school level, so we're just sort of repeating it to get back basics. Yes, then we've got obviously the length in the smallest length is nanometer, which is unit, micrometer and millimeter. 1 millimeter is the 0.001 meter, and then we've got centimeter. 1 centimeter is 0.01 meter, which means 1 meter has 100 centimeters. 1 centimeter has 1000 millimeters. The next one is decimeter. 1 decimeter is 0.1 meter. That means 1 meter has 10 decimeters. So 1 to 10 is 1 decimeter, 10 to 20 is 2 decimeters, and so forth. Then we've got meters and kilometers. 1 kilometer are 1000 meters. Then we've got the time. H is 1 hour. 1 hour has 60 seconds. 1 minute, 60 minutes, sorry. 1 minute has 60 seconds. 1 day is 24 hours, which has 1440 minutes, and this equals 86,400 seconds. 1 week has 7 days, 1 month has 30 days, a year has 360 days, and then we've got the mass, whereas 1 gram is 0.001 kilogram. 1 kilogram is 0.001 ton. Then we've got the volume. Volume is actually we've got the Dichte, which means the German word, which means the density. Yeah. So density is calculated by mass divided by volume in kg divided by meter cubic meters. Then the next mass item, Masseinheit, which means it's unit. Mass unit is the Leistung, which means how efficiency or energy. So we've got W, watt, then we've got kilowatt, then we've got megawatt. In joule, your second, or megajoule. Joule is, if you calculate your calories or on a diet, then you know how many joules are in your food and how much you should eat and energy your body uses, and so on and so forth. Yeah. Then we've got the Fläche, which means that's the area, which is in millimeter square. 1 millimeter square is 0.01 centimeter square. 1 centimeter square is 0.01 decimeter. 1 decimeter square is 0.01 meter square. 1 square meter, which means counted backwards, 1 square meter has 100 decimeter square. 1 decimeter square has 100 centimeter square. 1 centimeter square has 100 millimeter square. 1 acre has 100 meter square. 1 hectare has 100 acres, and 1 kilometer square has 100 hectares. Okay, the next unit is the Kraft or Last. That means it's a pressure, it's a power or something that is like a burden on you or something. So we've got Newton, then we've got kilonewton. This equals 1000 Newton, and then meganewton, 1 meganewton is 1000 kilonewton. Then we've got Newton meter, kilonewton meter, which is like a moment in Newton divided by meter. Kilonewton meter. So how much pressure per on your area. Yeah, now we've got also pressure and Spannung, which means that's all very not exciting. It's not really exciting, but yeah, there is some pressure on it. So pressure equals the Kraft durch Fläche, which means power divided by the area. In Newton divided by meter square, or Newton divided millimeter square, meganewton divided by meter square, Pascal or hectopascal, megapascal, bar, megabar, and then we go to volume, which means millimeter cubic equals 0.001 centimeter cubic, which means 1 centimeter cubic has 1000 millimeter cubic, 1 decimeter cubic has 1000 centimeter cubic, and 1 meter cubic has 1000 decimeter cubic, which equals a liter. 1 milliliter equals So 1 liter has 1000 milliliter. Yeah. So what we've got is tera, giga, mega, kilo, hecta, deca, which equals million, billion, million, billion, billion, million, thousand, hundred, and 10 times. Einzeleinheiten. Then we've got pico, nano, micro, milli, centi, deci. The same to billion, a milliard, millionstel, thousand, hundreds, and tens. Yeah. That was this part. Yes, then what is actually important to do drafting or architectural work, which is the teaching all about mainly, the conversion also from units, imperial units into decimal units, and inches into millimeters, and so on and so forth. So in the old days when they used chains and links. So 1 foot equals 304.8 millimeters, which equals 0.3048 meters. 1 foot has 12 inches. 12 inches to millimeters. 1 inch equals 0.0833 millimeters. One chain equals 9 inches. Open klammer, which means so 1 foot has 12 inches and 1 foot equals 304.8 millimeters. That was the most important thing to remember. 1 chain equals 9 inches multiplied by 25.4 gives you a value in millimeters. Then we've got links, which is a very old way of measuring things, but still appears in quite a lot of plans on council records from the old days. Yeah, and that's normally the English, British way or US way. Inch, foot, yards, statues, miles, square inches, acres, cubic inches, cubic foot, gallons, quarters, barrels, ounces, pounds, short tons, long tons, not wontons, we're not in China, so uns are like wontons, they're yummy. Yeah, those conversions into foot, pound, calorie, British thermal unit, horsepower, BTU, pound, horsepower, foot, second, mile per hour, kg, force, and yeah, all very confusing. So, never mind. 1 link equals 0.2011868 multiplied by the length gives you the meters. So just remember those formulas and don't worry about all the other old-fashioned rest of all those funny names, because in those days you just push the buttons in the computer and it just converts it for you automatically anyway, so you don't even have to think about it. Yeah, but before we had the computers and used to do everything by hand, obviously had to use those books and tables, and yeah, so it's still quite important to understand. Right, moving on. Yes, the Greek alphabet, quite important, because that's all the abbreviations derived from the Greek and the Roman alphabet. Alpha, beta, gamma, delta, epsilon, zeta, eta, theta, jota, kappa, lambda, mi, ni, xi, omicron, pi, rho, sigma, tau, epsilon, phi, xi, psi, omega. Then we've got the Roman letters, or numbers that they used to use. They're hardly being used those days, but we still learned it at school. So, like I is 1, X is 10, C is 100, MC is 1100, 2, 3, IV is 4, V is 5, VI is 6, V double I is 7, V triple I is 8, IX is 9, X is 10, XX is 20, triple X is 30, XL is 40. Oh, it's fashionable, isn't it? They use it for clothes. SX, XL is the bigger size of clothes. So, you see? The Roman numbers are everywhere. L is 50, LX is 60, LXX is 70, L triple X is 80, XC is 90, C is 100, CC is 200, triple C is 300, CD is 400, D is 500, DC is 600, D double C is 700, D triple C is 800, CM is 900, M is 1000, MC is 1100, M double C is 1200, M triple C is 1300, MCD is 1400, MD is 1500, MDC is 1600, MDCC is 1700, MD triple C is 1800, MCM 1900, and MM is 2000. Yeah, so it's quite important just to sort here to those numbers. Oh yes, they occur actually historically if we number the centuries, like BC before Christ and AD after Christ, and so on and so forth. So when the Roman Empire was formed around that time, so that's where it's still used in our days to know to number the centuries. Yeah, next one as a gradient. So you know the circle has 360 degrees, which is 6.28 radiant, is equals 400 gon. Yeah, which is just old ways of naming those, but still good to know, just in case. Kilowatt. So we already had look at all those. Yeah. The next teaching is about actually math and how to calculate properly, which is quite interesting and important to know. The basic math. Yeah, but we'll have a quick break, and we'll get back to calculation and mathematics shortly.